All right, Algebra 1. Hey guys, welcome back. We are getting into section 4 of chapter 4 today. Okay, this is entitled Solving Compound Inequalities. All right, I can really tell you these notes are so important. All right, this is a concept that does not come very naturally for most students. So pay close attention, watch the whole video. You might need to rewatch some parts. Especially when we get into the example problems, and make sure that you are truly grasping what is required of you for section 4. Okay, so I'm just being really honest, and as you can see in the first note there, these are super important. Pay close attention, write down any questions you may have and bring them to class, because as you watch the video, you may have questions, write them down, and then go back. Maybe you can answer your own questions. That's always the best method. But if you can't, bring those questions to class, address them during class. Make sure that you don't let this section just disappear, because the rest of the chapter builds right off of this section. Okay, so basically, what is the premise? You're going to be solving and graphing two inequalities, but on the same number line. Okay, so the step 1 is you're going to be solving two inequalities. Then you're going to take those answers and graph those answers onto one number line. Okay, now you will notice compound inequality, compound meaning two or more than one, and you're going to see words. The words are and, the other word is or. All right, but there will be problems where you don't see a word. You're just going to see one big inequality. Those problems, those inequalities are using the word and. So in other words, I'm saying you might see the word and, you could see the word or, but if you see no words at all, it is an and that is being represented to you. Okay, now let's go to and figure out, what does this word and even mean? The word and means that you, for your graph, this is specific to the graph, you are only focusing on the intersection. In other words, the overlapping part on that number line. In other words, again, if you were to graph and it says you're going to the less than side, then you have another one and it's going to the greater than side, there's going to be a point where those two graphs overlap. One intersects the other one. For an and compound inequality, you're only showing the overlapping part. You're not showing the part that goes off by itself. Okay, but on the contrary, the word or means that you are showing both inequalities. No matter what, they do not have to overlap. So you could have inequalities where the lines go totally away from each other, opposite directions. That would represent or, and you need to show that, and it doesn't matter that they don't overlap for an or. Okay, as you see, pay attention. Here we go, example problems. All right, so for the first example problem, we're going to translate a phrase, give you a sentence, translate it, and write it into a compound inequality. So I'm going to show you the steps to go through here. All right, the phrase is all real numbers that are greater than or equal to -3 and less than 5. Okay, when they're representing all real numbers, that's your variable, that's x. Okay, so let's go and start here. We're going to have two parts. We have x, all real numbers that are greater than or equal to -3, and then represent x again, because that's still all real numbers, and less than 5. So what I wanted to show you right off the bat is just these are the two inequalities that are being described in that phrase. Remember, all real numbers represents x, then the rest of it is telling you about the inequality aspect of it. So all real numbers x are greater than or equal to -3. There's the first inequality we wrote. Then put the word and. Now go back to the phrase all real numbers, and then skip to the end are less than 5. And that's the second inequality. Now what I want to show you how to do is let's try to put those two inequalities together and create a true compound inequality. The way you do that is you put your variable in the middle. Okay, you put your variable in the middle. And what we are representing here is that we have a 5 and we have a -3. Sandwiched right in the middle is x. All right, x is greater than or equal to on that side, but on this side, 5 right there. Oh, actually, sorry, let me erase that because the direction shifted right there. Now, if you take a look, this is exactly what we're representing up above it. All right, let's go back to that old school elementary style. Remember the alligator eats the bigger, or whichever one that it's going for there. So if you look at that right here, got that alligator eating the X, and you see how right over here, same thing. Let's shift colors. Over here, you see how the alligator is eating the 5? Same thing, look over here, alligator eating the 5. All right, so what I wanted to make sure you understood is how to write two individual inequalities and then rewrite that as a compound inequality that puts it all together. Okay, now let's move into example 2, where the first step is solve, the second step is graph. Okay, you'll notice there's no word. So remember back at the beginning, when there is no word here, what is it representing? It's representing the word and. So off to the side, we know this is representing and. Don't forget that because that's going to come back to us. All right, now, how do I separate these two? Because I'm given a compound, but I have to separate them into individual inequalities. And here's what we do. We're going to block off the two parts. Here's one part blocked right there. You'll notice, read it like a book from left to right. You got one inequality sign that you hit, but the second you come in contact with that second inequality sign, stop it. It blocks it off right there. So let's rewrite this. We have a -7 less than x minus 5. All right, the other color, now go on the right side and move to the left. We're going to go this way, and then boom, we block it off right there because now we have the other inequality sign being represented. Now let's rewrite that, x minus 5 less than 4. So I want you to take a close look. You might even need to pause the video here and see that from one compound inequality, I pulled apart, I extracted the two individual inequalities that made it. Now that I have the two inequalities, I now need to go and solve those two inequalities. All right, so let's go back to our blue color here. We now will be adding 5 to both sides. So that's going to be a -2. All right. Now let's do our red color here. We're going to add 5 to this one, and that's going to be x less than 9. Okay. Now, just so that it's a little clear with this blue one, I'm going to rewrite it. Because remember, I prefer the order to be the variable, the inequality, and the number. So x. All right. So pay close attention, always, always, to each step. Slow it down, pause it, track with me. Okay, so now we have the two answers, and there's our blank number line. So now we need to represent both of these guys. Remember the word and now you're going to see what I mean by the overlapping part. Okay, so let's show we have a -2. There's one. Actually, let's undo that. We don't need a highlighter. We do need a marker. There we go. And let's do it in green here so we can clearly see. We got 1, 2. We have an open circle, right? Because the inequality doesn't say or equal to. And then let's just save ourselves some time and say that that is all the way at +9. Again, an open circle. Okay, for x greater than -2, it would go this way. For x less than 9, it would go that way. Notice they're going towards each other. The overlapping part is going to be right there in the middle, because that's where the lines would overlap. And that's the only part that I need to shade or darken, because once they pass each other, there is no more overlap. And I don't want to show where they don't overlap. Okay, so there we go. Let's move into example number 3. Okay, again, I see a compound inequality that I need to pull out the parts, and the word "and" is going to be represented because they didn't write anything. So that tells me "and" is being used. All right, so we start from this side, boom, block it off right there. You can only include one inequality sign in each part. Now the other one, go this way, and boom, block it off right there. Okay, so now let's write each part. We have a 10 less than or equal to 2x plus 4. And on the other side, we have a 2x plus 4 less than or equal to 24. All right, let's solve each part. Subtract 4, subtract 4, 6 less than or equal to 2x, x. Notice it's going to look like I'm flipping the inequality sign, but really what I'm doing is I'm changing the order. The variable goes first, then the inequality, then the number. And we're going to get 3. Okay, so there's one of our answers. Now let's solve the second inequality. Minus 4, crossed out, minus 4. 2x less than or equal to 20, x less than or equal to 10. Okay, so both pieces are represented here. Now we're going to have the word "and," don't forget that. Let's say right about here is 3 and right about here is 10. Again, just save some time. Both of them, you will notice, say "or equal to." So I have to fill in the circle, because inequalities, remember that they say "or equal to." You got to fill in the circle. We are less than 10. We are greater than 3. So that means we will darken in between the two dots. That's the only piece we need to represent. Okay? Okay. Now, let's do another example, but now the word "or." We haven't done an "or" yet. We kind of like "or" because we don't have to pull apart a compound inequality. They give us both parts. Okay, so it's a little nicer that way. All right, let's jump into it. We'll do this one in blue. Minus 1, 3x. That crossed itself out. Less than. That's a -5, a -1, making a -6. X less than 2. So there's one of our answers. Okay, let's represent the other one over here now. Add 5. Add 5. That's gone. 2x is greater than 12. X greater than 6. Okay, so that's just the simple steps of solving multi-step equations where we're using an inequality. So that stuff we've done already. That's why we go through that pretty quick. Now let's represent our graph. Okay, there's our 2 points. Let's get our color green here. We're right here at 2. Let's go right here at 6. Both of these are open because they do not say "or equal to." All right. X is less than 2. X is greater than 6. You'll notice opposite directions. They're never going to cross, never going to overlap, but that's okay because it's the word "or," meaning you must just show both of them together, same number line. All right, again, this was the word "or." All right. Good. And whoa, guys, that was it. That was our last example problem. Okay, excellent. So go back, take a look at any of these that didn't make sense, review it, review it, review it. Bring your questions to class. I'll see you guys in the next one.